Okay, so let's continue with probability. Now, I'm sure you guys have seen Venn diagrams before, and Venn diagrams are used to depict certain events and whether those events have overlapping areas or not. So, let's say I have a sample space. This is all my sample space, let's call it S. And we have event 1 and event 2. Well, I can't draw circles, they look like potatoes, but imagine. So there are two events. Now, there is this overlapping area between the two events, right? Okay. So what's the probability of choosing an event that occurs in both of these? So probability of event 1 and event union event 2, and this U stands for union, all of them together. Okay, so the way we define this is the probability of event 1, obviously, plus the probability of event 2. But if I just add these guys, this common area will be double counted. So I got to take that away, so I'm not double counting. So probability of event 1 with intersection of event 2. This symbol, the upside down U, means intersection, or this common area. If there was no common area, if the two circles were separate, then your formula would just be that. But since you have a common area, then you don't want to double count. So you got to take away that common area. So that will be your formula. And that's also given to you on page 717. Okay, so let's take a look at example 9 based on what we just described. Example 9, it says, what is the probability that a club or a face card is drawn from a standard deck of 52 well-shuffled cards? Okay, so let's take a look at the solution. It says, as before, define an event E1, a club. So your first event is drawing a club. And how many clubs do we have? It's 13. So drawing a club, probability of drawing a club, which is your E1, is 13 out of 52. I'm sorry, you don't have to put parentheses there. 13 out of 52, there are 13 clubs. Then you have to talk about the probability of a face card. So the probability of a face card, let's call it E2, event 2, that is 12 out of 52 because you have 4, I think. Oh, I'm sorry, you have 3. You have king, queen, and jack, right? So there's 3 face cards, but you have 4 of each suit. So that's 12. So that's 12 out of 52. But are there some face cards that are clubs? Yes, there's 3 of them, right? If you look at this picture, there are, I don't know which one's clubs, but let's say these are the clubs. There's 3 of them that are face cards and clubs. So that's your common area. That's your overlapping area, which you have to subtract. So the probability of event 1 union event 2 is the probability of drawing a club plus probability of drawing a face card, but minus the common area, the overlap, which is 3 out of 52. Okay, so that's 15. I'm sorry, 25 minus 3, that's 22 out of 52, which is equivalent to 0.423 or approximately 42.3%. The probability of drawing a club which, or a face card. It's 42.3%. Or a face card, a club or a face card. Okay. Now let's look at this example, example 9b on the top of page 718. It says a survey of 100 voters was taken to gather information on critical issues and demographic information collected as shown in the demographic information collected as shown in the table. 1 out of 100 voters is to be drawn at random to be interviewed on the 5 p.m. news. What's the probability that the person is a woman or a Republican? A person is a woman or a Republican. So what's the probability? Now we have 100 people, right? So what's the probability of a person being a woman? You have 53 women out of 100. So that's why the probability of being a woman is 0.53. So probability of being a woman is 53 out of 100, or 0.53, because there are 53 women in the survey. Okay. What's the probability of being a Republican? That, how many Republicans do we have? 37 out of 100. And that's 0.37, right? But do we have any overlapping area? Do we have women that are also Republicans? Yes, we do. We have 17 of them, right? So the probability of women being Republicans is 17 out of 100, right here. 17 out of 100. So that gives you 0.17. So what's the probability of choosing a person who's a woman or a Republican? That will be probability of a woman plus the probability of a Republican minus their intersection, the probability of a woman being a Republican. So 0.53 plus 0.37 minus 0.17. So that gives you 0.73, or 73%. Probability, according to this survey, the probability of choosing a person who's a woman or a Republican is 73%. Okay, very, very good. I would like to also do problem number 28 from page 720, which is your homework page. So problem number 28, I hope everybody has that, problem 28 on page 720. It says a large law firm has a support staff of 15 employees. So we have 15 employees, okay. 6 paralegals, and 9 legal assistants, let's call them LAs. Due to recent changes in the law, the firm wants to send 5 of them to a forum on new changes. 5 of them. So we want to send 5 out of this 15. If the selection is done randomly, that means no order, so combination comes into play. What is the probability the group will have? A, exactly 3 paralegals. So let's do part A, exactly 3 paralegals. Okay, so we want to send 5 to forum. Okay. All right. So, how do we calculate probability? The total number of outcomes in the denominator. So what's the total number of outcomes? The combination of choosing 5 out of 15 employees, right? So that's your denominator. The part A is exactly 3 paralegals. So how many paralegals do we have total? 6. If we send exactly 3 of them, then how many legal assistants we can send? We are sending 5. So if 3 of them are paralegals, then we are sending only 2 legal assistants. Okay? So you can do this on the calculator. And the answer would be 0.2398, or almost 24%. Okay. Part B, sending exactly 2 legal assistants. So again, the denominator is the same. If you're sending 2 legal assistants, we have 9 of them, right? So how many paralegals we're sending? 3, because we're sending 5. 2 plus 3 is 5. So it's the same thing as part A, 0.2398. Okay? Well, I'm not doing it by hand. Just you can do that on your calculators. All right, part C. It's asking you sending at least 2 paralegals. Okay, at least 2 paralegals. All right. So the denominator stays the same. Now this one is going to be a little long. The denominator is still the same. We are sending 5 out of the 15 employees. Sending at least 2 paralegals. So if I'm sending 2 paralegals, how many legal assistants I'm sending? 3, right? Because if I'm sending 2 plus 3 gives me 5. So if I'm sending 2 paralegals, then I'm sending 3 legal assistants. Or I can send 3 paralegals, right? Because it says sending at least 2 paralegals. So I can send 2 paralegals, or 3 paralegals, or 4 or 5. So if I send 3 paralegals, then I have this 3. Then I'm sending 2 legal assistants. Or I can send 4 paralegals. Then I am only sending 1 legal assistance, because 4 plus 1 adds to 5. And when I say or, that's where the plus sign comes. So 2 paralegals, or 3 paralegals, or 4 paralegals, or 5 paralegals. So if I'm sending 5 paralegals, can I send any legal assistance? No. I stop right there, because I can only send 5 employees. So once I make all 5 employees paralegals, then there is no more room for legal assistance. That's why this is by itself. So at least 2 paralegals. So 2, 3, 4, 5. You do all of this, all of this, all of this, all of this, add them all together, divided by that, and it gives you a probability of 0.7063, or approximately 71%. Okay? All right, very good. You know, one thing, there was one thing I believe I missed covering in the last set of videos, not the last one, but on combinations. I just want to cover that real quickly. It's very fast. It's called distinguishable permutations. I'm sorry, on permutations, not on combinations. So this goes back to section 9-4. So distinguishable permutations. So there's a formula for it: n factorial over p factorial times q factorial times r factorial, and dot dot dot. Okay, what does that mean? What does that mean? So for example, if I give you the word Mississippi, okay, how many if I jumble all the letters, how many distinguishable combination of letters can I have out of this word? Well, first you count how many you have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 letters total. So n is the total number. So that's 11 factorials. Now, how many? Now, the denominator are what's repeating. So what's repeating here? Is m repeating? No. So forget about that. Is I repeating? Yes. 1, 2, 3, 4. 4 times. That's 4 factorials. Is s repeating? Yes. How many times? 1, 2, 3, 4. That's another 4 factorials. Is, what else is repeating? P is repeating. How many times? Twice. So that's 2 factorials. So you do all of that. We can do it by hand if you like. So 11 factorial is 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Am I crazy? Yes. All right. I can do it by calculator, but so 4 factorial is 4 times 3 times 2 times 1. 4 factorial is 4 times 3 times 2 times 1. 2 factorials is 2 times 1. Okay, let's see if we can simplify. 4 times 3 times 2 times 1, gone. 4 times 3 times 2 times 1. Let's see. We have 4 times 2, which is 8. We have an 8 up here. They're gone. We have 3 times 1, which is 3 times 2 times 1, which is 2. So 2 times 3 is 6. That's gone. So what's left? What's left is 11 times 10 times 9 times 7 times 5. Right? Everything else canceled. Therefore, cancel 6. Okay, so we can have 34,650 different combination of letters from the word Mississippi. So that's an example of distinguishable permutations. Let me double check something really fast. Yeah. Okay. So I forgot to copy that. To cover that. So I just want to do that one. So basically, we are done with chapter 9. Woohoo! Thank you, and I'll see and talk to you guys on Tuesday.